The first question, which of the following is the correct dimension formula for the capacitance is F? Okay, M, L, T and C stand for unit of mass, length, time and charge. Okay, so the question is asking find the capacitance dimension formula in terms of mass, length, time and C. Okay, that means charge. Okay, from definition of capacitance. What is that? F, actually C, but he in this question asking as F. Okay, capacitance F is equal to, okay, charge per voltage. Due to my facility, it is multiplied by Q and divided by Q. There is no change. Okay, so what happened? Q square by V into Q. Okay, but you know what is that? Voltage into charge is equal to what? Work done. What is that? Work done. So from definition of potential, okay, what is that? From definition of potential equal to what? Work done per charge, isn't it? Then work is equal to what? V into Q, voltage into charge. Therefore, capacitance F is equal to what? Q. Q is a charge. Charge is what? C square. Charge is what? Q. Charge is nothing but C square. So V into Q is replaced by what? Work, isn't it? So work dimension formula is equal to what? M L square T power minus 2. Therefore, dimension formula of capacitance F is equal to C square into M power minus 1 L power minus 2 T square. Okay, T square. That's it. The second question, the torque due to the force 2I cap plus J cap plus 2K cap about the horizon acting on a particle whose position vector is I cap plus J cap plus K cap would be. Okay, the solution for this question, you know, torque tau is equal to what? Torque is a vector. So torque is equal to what? R bar cross F bar. What is it? R bar cross F bar. So how you can do the cross product? You know very well. Det of R bar cross F bar is, what is that? I J K, I cap, J cap, K cap. Okay, or what is the position vector? I. So its coordinates are 1 1 1. Similarly, F vector I J K components are 2 1 2. Okay, which is equal to what? I cap into 1 2 ja 2, 1 1 ja 1 minus J cap into 1 2 ja 2 minus 2 1 ja 2 plus K cap into, okay, K cap into 1 1 ja 1 minus 2 1 ja 2. So what is that? I cap. Okay, this is 0. Okay, that means remaining what? Minus K cap. So this is the torque vector. Okay, that's it. This is the solution for this question. Right. The third question, a force F bar is equal to I cap plus BJ cap plus K cap is applied on a particle and it undergoes a displacement I cap minus 2J cap minus K cap. What will be the value of B? Okay, if the work done on the particle is 0. So work done is F bar dot S bar dot product of force and displacement is called, what is that? Work. Moreover, work done is equal to 0. That means work is equal to 0. Then dot product of force vector and displacement vector, what is that? 2 I cap plus B J cap plus K cap dot displacement vector I cap minus 2J cap minus K cap. So 2 1 ja 2, okay, minus 2B, B into 2 minus 2B, 1 into 1 minus 1. So we get 1 minus 2B is equal to 0. That implies 2B is equal to 1. That implies B is equal to what? 1 by 2. So this is the answer for this question. Right. The fourth question, a ball of mass 100 gram, that means mass is equal to what? 100 gram. Okay, is projected with velocity V is equal to 20 meter per second. Okay, at a 60 degree, that means theta is equal to what? 60 degree. Okay, with the horizontal, that means, you see, this is the horizontal. With this horizontal, a body making an angle theta 60. With this angle, I would like to project a body with a velocity equal to what? V. Okay, whose mass is equal to what? 100 gram. Okay, the decrease in kinetic energy. Generally, the body move against the gravity, so its velocity is gradually decreases. So its kinetic energy is also decreases simultaneously. So what is the difference in kinetic energy during the motion from point of projection to the highest point? That means difference in kinetic energy point of projection, it is at initial kinetic energy at initial point of projection minus final kinetic energy at of its maximum height. To see here, kinetic energy, initial kinetic energy is equal to what formula? Of mv square. Similarly, final kinetic energy which at of its maximum height, which is equal to half m into what is the velocity at highest point? At highest point, vertical component of velocity may be 0, but in entire motion, horizontal component of velocity remains constant. So at of its maximum height, what happened? It having vertical component of velocity. What is that? V cos theta. Okay, right. What is that? Half into m into v into cos theta. That means 1 by 2 whole square, isn't it? So which is equal to what? 1 by 8 m v square. Therefore, difference in kinetic energy delta k is equal to what? K initial minus k final, which is equal to what? Half m v square minus half naught. What is it? 1 by 8. 1 by 8 m v square, which is equal to m 8 is taken as common, 4 m v square minus m v square, which is equal to what? 3 m v square by 8. Therefore, delta k is equal to what? 3 by 8 into mass. 100 gram means what? 0.1 kg, isn't it? Into velocity. What is that? 20. 20 into 20. Okay. So finally, you get what is the value? 15 joule. While doing the simplification, you get this value. Why? Because 2 4 ja, 2 4 ja, 2 5 ja. Again 4 1 ja, 4 5 ja. Okay. Right. 25. Then it's 30. 15 joule. Okay. The answer is 15 joule. The fifth question. A tube of length L. So this is a tube of length is what? L. Is shown in the figure. Okay. The radius of cross section at the point 1 is 2 centimeter and at the point 2 is 1 centimeter respectively. If the velocity of the water entering at point 1 is 2 meter per second, then velocity of water leaving the point 2 will be. You see, the given is a tube of flow. Okay, this is a tube of flow. Into this tube at point 1 with a velocity v is equal to what? 2 meter per second. Okay. Moreover, the radius of cross section at the point 1 is r1 is equal to 2 centimeter, and at the point 2, this is point 2. Okay, is 1 centimeter. That means radius r2 is equal to what? 1 centimeter. Okay, then velocity of water leaving the point. Velocity of the water leaving the point. Here v2 is equal to what? This is asking. You know, according to equation of continuity. According to equation of continuity. What is that? Velocity of a fluid through any house pipe is inversely proportional to the cross section area. That means AV is equal to what? Constant. Therefore, A1 V1 is equal to what? A2 V2. Isn't it? So this is the larger cross section area through which some water is entered. Equal amount of water is leaving out. Okay, through second cross section which is less one, then its velocity is more. So from A1 V1 equal to what? A2 V2. A1 is given. What is that? A1 cross section area. That means pi R1 square into V1 is equal to pi R2 square into V2. So on both sides pi cancel. R1 equal to what? 2 square into V1 equal to 2 is equal to R2 means what? 1 square into V2 is required. So this is 8. That means V2 is equal to what? 8 meter per second. So from this end the water is coming out with a velocity of 8 meter per second. That's it. Right, the sixth question. A body of mass 100 gram is moving in circular path of radius 2 meter on vertical plane as shown in the figure. Okay, right. The velocity of the body at point A is given. the ratio of its kinetic energies at point B and C is, okay, suppose to see this is a vertical circle. On the circumference a particle is supposed to be revolve. You know its velocity at its lowest point, say called V1. Then you can easily calculate velocity at any point on its circumference. Suppose after some time the particle reaches this point P. At this point velocity is say called V theta. Why? Because this is the particle with respect to its initial position, make an angle say theta. So this is calculated based on conservation of energy. What is that? According to law of conservation of energy at point, suppose this point P, this is point A. Energy at point P is equal to what? Energy at point A. Okay, so energy is equal to what? Kinetic energy at point P plus potential energy at point P is equal to kinetic energy at point A plus potential energy at point A. Okay, therefore you want to calculate kinetic energy at point P. That implies Kp is equal to kinetic energy at point A plus UA minus UP. UA minus UP. Okay, so Kp is equal to kinetic energy at point A minus UP minus UA also in a right, isn't it? So Kp is equal to what? Half m velocity at point P. This is required. Is equal to half m VA square. That means velocity at kinetic energy at point A. Okay, minus what you know? UP minus UA. UP is the potential energy at point P. That means when the particle reaches point P, it covers some height h. Okay, so you know this is R. This is equal to what? R minus h. What is it? R minus h. So we may write the total. A is a reference point. So what is the potential energy at point A? 0. So the potential energy at point P is equal to what? Only remaining. So what is that? mgh. Okay, so on both sides mm is cancelled. Velocity at point P, that means Vp square by 2 is equal to Va square by 2, that is only remaining, into minus m into g into h. G into what? H. Here h is calculated. What is the height raised from this right angle triangle? This is point O. So what happened? Cos theta. This cos theta. This is the adjacent. That is the required. R minus h by r, isn't it? That implies r minus h is equal to what? R cos theta. That implies h is equal to what? R minus r cos theta. This is the height. So total energy at point P, Vp square by 2 equal to Va square by 2 minus G into h into h. In place of h you can write that one. H is equal to what? You can take r common. R into 1 minus cos theta. So Vp square is equal to Va square minus 2gr into 1 minus cos theta. 1 minus, that implies Vp is equal to under root Va square minus 2gr into 1 minus cos theta. This is the equation is help to calculate energy at point B and energy at point C in terms of angle. Okay, right. So we're getting finally velocity at a point on the circumference of a circle when it makes an angle theta is equal to this thing. So what is asking? Find the ratio of kinetic energy at point B to the kinetic energy at point C. So kinetic energy at point B to the kinetic energy at point C is equal to what? Half m v b square, velocity at point P, to half m v c square, velocity at point C. So this half m is cancelled. Then you can compare velocity square at point B and C. Then you get the ratio of kinetic energies. So velocity at point B is equal to what? Va. That means velocity at point A already given, that is equal to 10 meter per second square. So equal to 10 square. That means what? 100. Equal to what? 100 minus 2. G is equal to what? 10. R is equal to radius is already given 2 meter into 2 minus 1 minus cos 30. Cos 30 because B is make an angle 30. So 1 minus 30 means root 3 by 2. By similarly velocity at point C, that means velocity at point A whole square, that means what? 100 minus 2 into 10 into 2. Why? Because 2 0 into 1 minus 1 by 2. Why? Because cos 120, because point C make an angle 30 plus 90. What is that? Cos 190. Cos 190 is equal to what? cos 90 plus 30, which is equal to what? Minus 30. So which is equal to what? Minus 1 by 2. So you get finally, therefore, velocity at point B whole square by velocity at point C whole square is equal to 100 minus 40 plus 40 into root 3 by 2 by 100 minus 40 into 1 plus 1 means 3 by 2. Okay, right. Which is equal, that implies VB square by VC square is equal to 60 plus 40 means what? 20 root 3 by 26, that means 40. So finally get 20 taken as common, 3 plus root 3 by 2, isn't it? So this is the answer for this question, right? The seventh question, a small rigid spherical ball of mass m is dropped in a long vertical tube containing glycerin. The velocity of the ball becomes constant after some time. If the density of the glycerin is half the density of the ball, then the viscous force acting on the ball will be, you see, a small rigid spherical ball of mass m is dropped in a long vertical tube containing glycerin. Suppose this is a long vertical tube containing glycerin. Okay, into this long vertical tube, okay, a small ball, small spherical rigid ball is supposed to be dropped. What happened? Due to its weight, it is, okay, falling down. At the same time, when a body is traveling through any fluid, it experiences a force called force of buoyancy. Okay, moreover, this liquid is more viscous. Glycerin is a viscous fluid. So it is also experiencing what? Viscous force Fv. So whenever this downward force is balances upward force Fe and Fb, then the ball attains, okay, constant velocity. Okay, and if the density of the glycerin is half the density of the ball, density of ball is supposed to be D. Okay, density of glycerin is given half the density of the ball. This is the given statement. Okay, so at balancing condition, here balancing condition means the downward force is supposed to be equal upward force. That means downward weight of the ball is balances upward acting viscous force plus force of buoyancy. Force of what? Buoyancy. Okay, so what happened? The ball attains constant velocity after some time. Okay, so find the force of viscous. That means Fv is equal to, what is that? W, weight minus Fb. Weight is equal to what? M into G. Force of buoyancy, M into G. Okay, M into G. Here mass is equal to what? Volume into density of ball into G minus mass is equal to volume into density. What is that? Density of, okay, glycerin, okay, into G. Density of glycerin into G. Okay, right. So here, density of the ball, V into density of the ball is D into G minus V into density of glycerin. What is that? D by 2 into G. So force of viscous Fv is equal to what? When you take it, 2VdG minus, okay, VdG by 2, isn't it? Therefore Fv is equal to what? VdG by 2. VdG by 2. Now volume density is equal to what? Mass. That means it's nothing but what is a mass into G by 2. So this is a viscous force acting on this, okay, small rigid spherical ball. That's it. The eighth question. The maximum percentage error in the measurement of density of a wire is, what is it? Density D is equal to what? Mass by volume. Mass by volume. That means m by volume of a wire. What is that? Pi r square into L, length. Okay. So maximum percentage error. Maximum percentage error. Therefore, maximum percentage error. Percentage error while calculating the density of a wire. What is that? Delta D by D into 100 is equal to what? Delta M by M. Okay. Plus. You know, density depends on mass, radius, and length. Okay. So, total. Suppose the change in, that means maximum percentage density error depends on all the variables. So delta m by m into 2 into delta r by r plus delta l by l into 100. Therefore, delta d by d. Okay, delta d by d. Okay, is equal to, what is the delta m? Delta m is equal to what? Delta m. What is that? Mass. Mass of the wire. Delta. This is 0.003 by mass 0.6 plus 2 into delta r. What is the delta r? 0.01 radius. 0.01 by r radius 0.5 plus delta l 0.05 by 10. Okay, into 100. Into what? 100. Okay, so while simplifying, this is equal to 3 into 10 power minus 3 by 6 into 10 power minus 1 plus 2 into 10 power minus 2 by 5 into 10 power minus 1 plus 5 into 10 power minus 2 by 10 into 100. So while doing 0.5 into 10 power minus 2 plus this is equal to 0.4 into 10 power minus 1 plus 0.5 into 10 power minus 2 into 100. So its value is equal to 0.005 plus 0.04 plus 0.005. Okay, into 100. So finally, while doing, we get 5%. Okay, that's it. The ninth question, assertion and region type. Assertion is what? A simple pendulum is taken to a planet of mass and radius 4 times and 2 times respectively than the Earth. The time period of the pendulum remains same on Earth and planet. Okay, to see whether this statement is correct or not, we can discuss. A simple pendulum. So what is the time period of a simple pendulum? Time period T of a simple pendulum equal to 2 pi into under root L by G. So the pendulum time period is depends on length and acceleration due to gravity on that planet. Okay, so what is given? This is on Earth. Time period of a pendulum on Earth T is equal to. Okay, so time period of pendulum at another planet TP is equal to root over L dash by G dash. What is that? L dash by G dash. Okay, so what is given on Earth? On Earth, mass m1 is equal to m. Okay, okay. Its radius r1 equal to what? R. Okay. Later on planet, mass m1 r1 is what? What is that? Mass m is 4 times 4m. Okay. Moreover, radius r is equal to what? 2 times. Okay, right. So on planet G is equal to G. That means on planet G is equal to what? G. on another planet G dash is equal to what? You know from relation between small g and capital G is equal to what? Gm by r square. You know very well. G is equal to Gm by r square. Okay, that implies G is equal, that means G dash is from G is equal to Gm by r square. That implies G dash is equal to what? G into mass. What is the mass? 4m on another planet. Gm by r square means what? R is equal to what? 2r. 2r whole square is equal to what? That means G into 4m by into G into 4m by 4 r square. So this 4 is cancelled. That implies G dash is equal to what? Gm by r square. So on Earth and on planet, okay, G is equal to Gm by r square. On Earth and on the given planet, both are G is same. So there is no change in time period. Okay, so assertion is what? Correct. Okay, the time period of the pendulum remains same on Earth and planet. Correct. Next, reason. The mass of the pendulum remains unchanged on Earth and the other planet. You know what is the time period of a pendulum? T is equal to 2 pi root over L by Z. In this equation, there is no mass term is involved, isn't it? In this equation, there is no mass term, so that it is correct. That means mass of the pendulum remains unchanged at Earth and the other planet. It is also correct. That means reason is also correct. But this reason is not correct explanation for the assertion. That is the exact answer for this question. Okay, right. 10th question asked, given are statements for certain thermodynamic variables. What is the first option? Internal energy, volume and mass are extensive variables. Pressure P, temperature T and density are intensive variables. Volume, temperature, density are intensive variables. Mass, temperature and internal energy are intensive. So the question based on what is that? Extensive and intensive. So first of all, you know about what is extensive variables. What is extensive? Do you have any idea? Okay, what is that? Extensive is the property of a system. What is that? The property of a system. The property of a system. You know, system, what is the meaning of system? Tell me. Okay, system means that depends on. The property of a system that depends size or mass. That means mass means what? Amount of matter. Size or amount of matter. Amount of matter. Okay, in system. Amount of matter in system. Amount of matter in system means what? Meaning. Its meaning. What is it? Mass. Okay, that means it meaning its its value is proportional to. Its value is proportional to mass. Okay, that means size. Mass means what? Size. So that when a system is there, for example, so what are that example? Internal energy. Why? Because a system is there, it having a possess some position. So due to position, it possesses some energy. That energy is called internal energy. Okay, energy due to mass. That means mass is equal to what? That means mass. Mass means where there is a volume is there, as well as density is there. Okay, so these are the variables are called extensive variables. So next one is called intensive variables. What is that? Intensive. Okay, what is intensive? Tell me. Okay, intensive variables are properties. What is that? These are the properties. The properties are the property of a system. What is that? The property of a system does not depending on amount of matter. does not depend on amount of matter or size, amount of matter or size. Okay, for example, okay, whatever may be the amount of matter, okay, it is having some pressure, okay, due to system possesses, okay, at some position, that is due to its position possesses some temperature, what is that, having some density, okay, chemical composition, okay, refractive index, what is that, refractive index, okay, similarly specific heat capacity, yes. So these are some of the examples of intensive parameters of a thermodynamic system. So extensive parameters are depends on size or amount of matter, okay, but intensive are not depending on size or amount of matter, okay, right. So according to this one, intensive, internal energy, okay, yes, internal energy, volume and mass are the extensive, right, it is correct. Okay, intensive, pressure, temperature and density, yes, this is intensive. Volume, temperature and density, volume is not comes under intensive, it is extensive, so it is not correct, mass m, temperature, okay, temperature is not comes under extensive, it is comes under intensive, so that, okay, extensive means what, so this is also not correct, sum of the club in this one. So according to given, option A and B are correct, that's it. The 11th question, for a diatomic gas, if gamma 1 is equal to Cp by Cv for rigid molecules and gamma 2 is equal to Cp by Cv for another diatomic molecule but also having vibrational modes, then which of the following option is correct? Okay, to see, for gamma, that means ratio of specific heats, gamma is equal to what, you want to calculate gamma for any kind of gas, diatomic, monatomic, okay, polyatomic, whatever may be it, okay, which is equal to what, 2 by F plus 1. Here F is equal to what, degree of freedom, okay. Here to see, for diatomic gas, for rigid molecules, okay, for rigid molecule means that is not vibrate, okay, that means without vibration mode, okay, gamma, for it, gamma, that means, sorry, F, degree of freedom for rigid molecules, that means without vibrational, its degree of freedom F is equal to what, 5, okay, that implies gamma 1 is for diatomic, which is a rigid, that means it is not having any vibration mode, so gamma 1 is equal to what, 2 by F, F means what, 5 plus 1, okay, which is equal to 0.4 is equal 0.4 plus 1 is equal to what, 1.4. So for diatomic gas, okay, for rigid molecules, gamma 1 is equal to what, 1.4. Next, for rigid molecule with vibrational mode, with vibrations, its F is equal to what, 7, that implies gamma 2 is equal to what, 2 by 7 plus 1, okay. So how much you get, 0.73 is 20, that means 7 2 is 0.2 plus 1, that means what, 1.2. What is that, 1.2. So from this you can write gamma 1 is greater than gamma 2. Gamma 1 is greater than gamma 2. So according to given option, option 4 is the correct one. Okay, right. The 12th question, a tube of length 1 meter is filled completely with an ideal liquid of mass 2m and closed at both ends. The tube is rotated uniformly in horizontal plane about one of its ends. If the force exerted by the liquid at the other end is F, then angular velocity of the tube is root over F by alpha m. in SI system, the value of alpha is, to see what is given, a tube of length 1 meter. Suppose take this is a tube, okay, of length is equal to what, 1 meter. This is a 1 meter length tube, which is completely filled with liquid, which is it is completely filled with what, liquid, okay, of mass is equal to what, 2m, of mass is equal to 2m, and closed at both ends. The tube is rotated uniformly in horizontal plane about one of its end. Suppose this is allowed to rotate about an axis which is passing through its one of its end. So what happened? This total liquid exert force on this end. This is F. Okay, then angular velocity of the tube is, that means given angular velocity omega is equal to F by alpha into m. The value of alpha is, moreover given mass m is equal to what, to m. Okay, the length, the from this axis center of mass is located at L by 2. So R is equal to what, L by 2. From F is equal to, when a body is rotated in circular path, what is required? Centripetal force is required. F is equal to what? mr omega square. Therefore F is equal to, mass is equal to what, 2m, R is equal to what, L by 2 into omega square. This 2 is cancelled. Therefore F is equal to ml omega square. Therefore omega square is equal to what, F by m into L. That implies omega is equal to root of F by m into L. Okay, in place of given, compare, now compare it with the given. What is that? Omega is equal to F by alpha into m. Therefore alpha is equal to what, L. That's it. Okay, right.